Hi everyone, welcome to the Dataholics YouTube channel. And in this video, we are going to study and practice sets in Python, right? So a quick recap, in our current Python for data science playlist, we have already covered a lot of topics like variables, data types, strings, operators, functions, parameters, arguments, generator functions, recursions, lambda functions. After that, we have also covered about loops, for loop, while loop, their use cases. We have created 3 different projects in a separate playlist called Python project. So to access those videos, to watch those tutorials, or to do those projects, come at the channel the_dataholics, right? So Python for data science, this is the tutorials playlist, and here you have another playlist for Python projects, right? So in which we have created 3 different projects using multiple concepts in SQL like conditional statement. And by the way, conditional statements are also covered in the tutorial using different data types like list, set, all dictionaries, functions in Python. So we have used mostly all the concepts to build these projects. So you can practice these projects, watch these videos, copy the project, do some enhancements, and practice uh, Python in a very practical manner, right? And I'll keep updating this playlist to add more projects, right? But now in this video, we are going to study and practice sets in Python, right? And this is the content which we are going to cover. What are sets in Python? Why do we use them? This is very important. The properties of set, which differentiates it from typical list and tuple, creating a set, and concepts about nested set, whether they are possible or not, looping over a set, editing a set, we can how we can add elements, update elements, remove elements or something. Then we will study about functions in set, right? Different functions which are inbuilt for set, and operations on sets, and then we will see about quick exercises, right? So without wasting much of the time, let's get started. So these are some of the theory which we need to understand and remember in sets, especially for your examination or interviews. But before directly trying to cram this theory, let us just read it once and try to implement everything practically. So what are sets? Sets are nothing but a data type, or some people call it as data structure in Python, which is used to store multiple values in a single variable, right? But if actually like list and tuple. In list and tuple also, we can create multiple elements at the same time in a single variable, right? But what is the differentiation between a set, list, and a tuple, right? So set do not allow duplicate values. So in other words, we can say set only contains unique values, right? So why do we use them? For an example, let's say you are creating an employee database, or you are creating a student database, and there are some information about any employee in the company which are unique to every employee, like their email ID, like their employee ID, right? Similarly, like Gmail, we all, like, there are crores of users, hundreds and thousands of users on Gmail. Everybody has a different Gmail ID, correct? So such informations cannot be duplicated for 2 customers. So, and such informations can be stored in a set, correct? Then set, a second property of the set is set do not have indexing or slicing. All then they store the data in the memory based on hashing, right? So unlike list and tuple, where we do have indexes, we can access the elements of list and tuple using indexes. Sets do not have indexing, right? Third property, sets do not allow mutable data types. So we will prove this point to you. Just read it and understand it. Like lists, but strings and tuples which are immutable, we can store them inside a set, correct? So the elements of the set can only be immutable, like integer, float, string, tuple, and all. We cannot have mutable data type like a list inside a tuple as an element. I'll prove this point to you very soon. Set itself is a mutable data type, right? Correct. Mutable data type means we can add or remove some elements from the set. And the last point, sets are unordered collection of data. Unordered means it is not necessary that set maintains the order of elements. The sequence in which we store the element, it is not necessarily saved in the same sequence, right? So let us try to practically see all of these points. But before that, let us try to create a set. So this is how do we create an empty list. L is equal to open square brackets. T is equal to open parenthesis. S is equal to open curly brackets. So sets are usually created using a curly brackets. But if I write S is equal to curly brackets open and close, it will be an empty dictionary. Let me prove it to you. Print type of S. Correct? If you see, once this cell will execute, it will say type of, oh, not types actually. That is why it is giving an error. It is a dictionary, see? So this is not how we create an empty set. So then how do we create an empty set? By using this set method, right? So if I tell you now, print type of S, let's say S1, correct? Type of S1, it will be a set. So I hope you now you're able to understand how do we create empty set using the set method, not using this curly brackets open and close, right? So this is how do we create a set. Now, how do we put elements inside a set? There are two methods again, using curly brackets like this or using the set method. So for an example, if I write x is equal to curly brackets 1, 2, 3, 4, 8, 8, right? You see, we have written 8 twice, duplicate. But I told you in the earlier that sets do not allow duplicate values. They can only store unique values. So see, print type of x and print x. So if I see the type of x, it is set. And when I print x, it is only printing 1, 2, 3, 4, and 8. We have written, although we have written 8 two times, but it is printing only one time because set are stored in this manner only. It will automatically remove the duplicate value. So this is the point proved, the one of the properties that set do not allow duplicate values. I hope now you're able to understand it and it makes absolute sense. In this same set, we can also have multiple data types like A, Akshat, right? String is here, Boolean is here, comma, float can be here. So multiple data types can exist in the same set. That is not an issue at all. So if I have only same data type, that is called a homogeneous set. If I have multiple data types in a set, it will be called as heterogeneous set, right? So I hope we are clear till here. How do we create an empty set? How do we create a set with some elements? And duplicates are not allowed. Let's see about indexing. So usually when we are talking about a list and a tuple, we can access all of these elements using indexes. Indexes start from 0 till n minus 1. If you are not clear about indexes, maybe you can watch the video about strings. Correct? I have talked about indexing in detail. So how do we access the element of a set? If I say x of bracket 2, when I run it, it will give an error and says set object is not subscriptable. So because indexing is not present in the set, so we cannot access the items of a set like this. Then how do we access the items of a set? I'll just give you a hint here and we will see it later. To access the items of a set, elements of a set, we can use loops, right? So that is about how do we access the items of a set. And this is the second property which is proved, that sets do not have indexing, correct? So that is the second point. After that, we have created different types of sets here, like you just see and practice, revise it here. Type of this S1, S2, all of this. Now, the point is, set itself is a mutable data type. Like for example, if I say S is equal to 1, 4, 5, 7, 3, and if I say S dot add, we will see about add function later on also, but let's say I want to add 31 here, and then I print S. Before adding, if I print S, you see, so previously S was 1, 3, 4, 5, and 7, but now S is 1, 3, 4, 5, 7, 31. So one element is added at the end. It is not necessarily always added at the end only. Keep in mind, correct? So this property proves that set is a mutable data type, because mutable means when we can add or remove some elements. If I want to remove S now, 31 now, S dot remove 31, and if I print S now, you will see now 31 is removed. So that this point proves the mutability of a set, correct? Mutability of a set. Now, if I want to add in the same set, if I want to add, please pay attention here. This is a very important point which we are going to discuss. Add. If I want to add multiple elements like 1 comma 2, can it be done? After adding single element 31, after removing it, printing it, in this portion of the code, it is giving an error. See, the original set, after we have added 31, after we have removed 31, it is giving an error. And the error is unhashable type list. So this is the another property of set, that set does not allow mutable data types in them. So we cannot store a list which is a mutable data type inside a list, inside a set. Why? Because set elements are unchangeable. So please mark this statement which I'm going to say. Set itself is mutable, but the elements inside it are immutable. Please keep this statement in your mind. Correct? So elements inside it are immutable. Immutable like string, tuple, integer, float and all. Right? So now I'll just put it as a comment so that it do not throw error again and again. Now if I want to add multiple items like using a tuple, so s.add, same thing I'm adding 23 comma 42 43, let's say, right? And if I print s now, you will see it is working fine. This was the previous set, and after that it is adding one more element which is a tuple. Inside the tuple we have two different elements. Correct? So what do you think? Please tell me in the comment section, what is the length of s now, and actually before this and after this. If you are able to understand, please let me know your answer. Before adding these two elements, this tuple, as actually the length of the set would be 1, 2, 3, 4 and 5. After adding this tuple is considered as a one element. Inside it we have two data items, but they are wrapped in one element only, so it will be considered as one item. So 5 then 6. See, the output are 5 before adding the tuple and 6 after adding the tuple. Right? So we can very easily add a string, tuple, integer, float or any other immutable data type inside a set as an element. But we cannot store any mutable data type like list inside a tuple as an element. So please keep this point in mind. And hence we are proving set is mutable data type. So I hope now all the properties of set are clear by now. Sets are unordered, mutable data type, does not have indexing, does not allow duplicate values, right? So these are the properties of set. Going forward, how do we access the items of a set, right? So all of these exercises are for you to practice different kinds of data entry things. So see, when we are adding a list inside a tuple, it is giving an error. When we are adding tuple inside a list, it is going fine at tuples and string because they are immutable actually. But the concept of nested sets come here. Nested set means set inside another set. So see, set itself is a mutable data type, and the property of set says set do not allow mutable data type inside it. So we cannot store a set inside a set. So there is no concept of nested set. Correct? So see, I'm saying S5 is equal to a set. Inside this, I am adding one element like this set 1 comma 2, another element like this, which is a list. So both of these lists and set, both are mutable data type and they are not allowed inside a set. That is why this point is giving an error. I hope now all of these are making sense to you, right? So these are different properties of set. Just do some practice. If I try to do indexing S2 of 0, it will give an error. S2 of -1 give an error, because since there is no indexing, so you cannot access any element or you cannot slice a set using a slicing. So all of these things will give an error. Now, one very important thing to note here is set is a mutable data type. We can add an element to the set or we can remove some existing element from the set, but we cannot edit items in a set because indexing is not allowed. For example, if I say first, let's say let me show you S2 first. If it exists, okay. Now let me just run the code from above. S2, where do we have S2? Yeah, in this code we have S2. After running all of this, let me, yeah. So see, this is the current set S2, 1, 2, 3, 5, 7. It's okay, good. Now, if I want to access these items using indexing, all of these will throw an error. But if I want to do this, updating an element in the set, let's say I want to change the item at second position, for an example, is with 100. So this is item assignment. I want to edit the element at second position, second index. Let's see what happens. Before, see, it is printing the original set S2, but this operation is giving an error and says set item does not support item assignment. We cannot edit a set, element of a set. We cannot edit the elements, items in the set. Correct? So it's very fair now. Sets are used like so. Now, by understanding all of these properties, let us try to imagine about the utility of a set. For example, you are building a good application. Maybe you are building something for your company or for your startup. So where do we use set? Whenever you want any data type which does not allow duplicate values, which does not allow editing the items inside. For an example, my blood group, it will never change, but it is not unique for all. So blood group cannot be stored in a set. So let us try to think about some utility, and you can also come up with some use cases of set in the comment section. So if you can think of something, let me know in the comment section. But what I can think of right now is employee ID or student ID in the college. See, your student ID will never change throughout your college, and nobody is allowed to edit it also, right? Throughout your 3 year, 4 years, or whatever degree you have, it is not allowed to change. Nobody should edit your student ID, right? And no two students have the same student ID, or no two employees have the same employee ID. So such items can be stored in a set because they do not allow duplicates and they do not allow editing any elements. But yeah, a new employee can join the company, a new student can join the college. So a new element can be added or removed from the set, right? So I think this is a very good example. When do we use it, right? So I hope now it is clear about slicing and everything. And yeah, here I have some points for you to observe, right? So let's say I say S is equal to whatever set. This is the current set, right? If I say print S, type of S, it will be set, right? ID of S will give you the error address of the set. But let's say then I create a list L is equal to from the elements of the set. This is nothing but typecasting to convert the data type of a set into a list. Correct? Print L, it will be the address, the list L. Print ID of L, the address of the list. What do you think? The ID of this set and the ID of this L, will they be same or different? They'll absolutely be different because we are not changing the original set. The original set still remains same, S. We are creating a list out of the elements from the set. Correct? So see, this is the address of the set in the memory. This is the address of the list in the memory. So these are some just point of observations. They are very rarely used, to be honest. But I always try to tell these to the learners because I want, and this is my style of learning, to observe deep points. Right? They'll help you to advance your career. They will make you a very good habit of learning. So please try to focus. Similarly, try to do it for tuple or list or something like that. You will have different observations anytime. For an example, here we have observation. We have already studied about it. But yeah, let's revise. A is equal to 5. I say print ID of A. So it is an integer. ID of A will be the address of this element A. And then I say B is equal to A. Print ID of B. So see, now this time the address of A and address of B both are same. Why? Why? Because when I say B is equal to A, I am handing over A to the B. When I say handing over A to the B means everything related to A will be transferred to B. Just imagine like in the historical situation when a king conquers another king. So the king who loses the battle will lose everything to the winner, right? Their empire, their staff, their treasures, everything. They will be handed over to the winner king. So in a similar manner, this is called as object assignment. And whenever we assign any object to it, object assignment actually, right? Object assignment means everything related to the object, their value, their address, and everything will be transferred to the new object, new variable, right? So just a point of observation actually, correct? So this is about how do we cannot edit a set, of course, but yeah, trick can be used. We can convert the set into a list. Similar thing which we have seen in tuple also. We can convert it into a list, then we can edit the list and convert it back to the set and print the set, right? But yeah, this is just a hack which should be avoided, but in emergency situations we should do it, correct? So just watch these things. Now let us try to see some functions inside a set, right? So see, sets are indeed mutable. Adding element to a set using add function, we have already studied about it. My set is equal to 1 2 3. If I say my set dot add 4, now the next element will be added as 4. So if you print my set, it will add 4 to it. See, after that I say uh, my set dot remove 3, it will remove 3 from the set, and then if I print it, so it will print 1 2 and 4 only. So add function, remove function. Then we have clear function. Clear, what is clear function? Clear function is used to empty the set, right? The set will remain there, but all the elements from it will be deleted, will be removed. Clear, right? So see, after that the set becomes an empty set. Then adding elements to a set using union operator. So let's say these are two different sets, my set 1, my set 2, and you can add actually combine the elements of a set. If you remember, we to do this such thing in list on tuple, we write like L1 plus L2. They will combine the elements of list, combine the elements of tuple. But to do the similar operation in set, we use union operator, correct? Or this could also be done like this: print my underscore set 1 dot union my underscore set dot set 2, right? So this will also do the same operation like this. But what if I want to add multiple items to a set? To add one item to a set, we have add function, right? We have seen here. But what if I want to add multiple items? Then we have update function. You see, my set 1 is equal to 1 2 3, my set 2 is equal to 3 4 5. If I want to add all of these elements in a set, multiple items, so my set 1 dot update my set 2. So my set 1 will contain the elements of set 1 as well as set 2. So this is just like a union operator. I'll just write it for you as a comment, just like union operator. It will combine the elements from both the sets actually, right? So this is to add multiple items in a set, right? Then how do we delete items? So see, s is equal to this, s1 is equal to this. I say s print s1, so it will print the set s1, the values inside it. But if I say delete s1 of 0, it will throw an error. Why? Of course, because 0 indexing is not allowed in set, right? But if I say delete s, yeah, it will be performed because the whole set will be deleted, right? So think about it now. We cannot delete individual items from a set using the delete function using indexing. We can use remove function for that, but we cannot use indexing for that. But if I say delete s, I have not given any index, so it will delete the entire set, the elements inside it as well as the set itself. Everything will be removed, right? So delete function, clear function, remove function, and pop function. Pop function generally deletes the last element, but since sets are unordered, so last is decided as per the hashing, not indexing, correct? So these are some of the methods to add and remove elements from the set. Then how do we access items of a set? Let's say s, this is the set, right? If I want to loop access over all the items of a set, so what I can do is I can use the loop for I in s. What is in is a membership operator, correct? Print I. So this is how do we access all the items of a set, right? So to access the element of a set, we cannot use indexing, but we can use loops. Now if they ask you to print all the even numbers, all the prime numbers from the set, instead of printing, you can just put the function to check prime or logic to use even or odd, check even or odd, right? So this is how do we can do that. Set operations, just like in basic mathematics, we have set union, we have intersection, we have difference. Very similarly, we have here also s1 s2. So concatenation s1 plus s2, this does not work like this. It works like s1 union s2, right? s1 multiplied by 3, it will not work in set, right? So because uh, set does not allow this operation. This is how sets are created in Python actually, right? So that is the thing. Yeah, we do have membership operators in set. Like if I say 1 in S1, so if 1 exists in S1, it will be true. Otherwise, it will be false. Like say, see, output is false because in S1, if I say uh, print S1, see, in S1 is an empty set actually. So 1 in S1 is false, of course, because 1 does not exist in set. But if I say 1 not in S1, it is true. Okay, so we have to print both of them to see both of them actually. Print 1 not in S1, see. 1 in S1 false, 1 in not in S1 true. So this is how a membership operator works in set. So now there are some inbuilt functions like length to give you the length of the set, number of elements, maximum element of the set, minimum element of the set. These are very pretty easy, so I do not want to use much of the time here. Right. Sorted of S1. Okay. Now let's create a set first. Okay. Let's say we have S3. See this. Oh, actually, this is giving an error because in S3 we have integers as well as string also. So this cannot be compared. So they cannot be sorted. But let's say if I create another set, S3 is equal to S3 is equal to let's say 89 comma 34 comma 57 comma 90 comma 1 comma 23. These are the elements. Print S3. Then I say sorted of S3. Then print S3 again. And also let us try to see the type of S3. We will have a very good observation here. Right, see. Now initially the set was 134 23. This is sorted, right? So yeah, this is print S3. Type of S3 is a set. But when after we sorted it again, when it is printing set, it is again printing in the ordered manner, in the ascending order actually, right? And the type remains the same. Correct. So this is how sorted function works in set. Now there are few more functions like union, as I told you, to combine all the elements of different sets. Intersection, to find the common elements between two sets. Correct. To understand this thing, I think we can I can show you a diagram here. Set operations. Let me show you some images here. Correct. Like this. See. So the first image, which is having all the elements, all the things are red. Right? If you see here the big image, union, the first image which is having all the red, it's called union because union means all the elements from both the sets. Second image is intersection, the common element between the two. See, there are two circles and it is highlighting only the intersection area, the common area between both the sets. Then exclusive or subtraction. Subtraction means like let's say if I say S1 minus S2, so it will remove common elements between set S1 and S2 from S1 minus S2. Correct? So S1 difference S2. Let me show you practically here also using the code. Let me put myself here and yeah. So see, S1 and S2 both are two sets. Let me print it for you first quickly. Print it also. Print S1 union S2. So what it will do, it will print all the elements of set S1 and S2. Now here I will print this. Let me copy it quickly. So S1 dot symmetric difference, S1 dot difference. Let us see all of these operations. Disjoint also, subset also, superset also. Subset means if S1 is a subset of S2, yani like S1 is a part of S2. See, so S1 actually is empty. Okay, no worries. S1 is empty. So S1 union S2 will be S2 only. But like, I think this is not a good example then. let me create S1 and S2 here. S1, S2 is equal to, correct. S1 is equal to, let's say, 1, comma 4, comma 5, comma 7, 9, right? Now see, so S1 is this, S2 is this. So what is this? This is containing all the elements from S1 till here, and these are the elements from S2, correct? Yeah, and observe here. See, this is not in ordered. See, 1 is from set S1, 34 is from set S2. This all of these three elements are from set S1. These are from set S2. So unordered collection, right? So S1 combine S2. Now, second is S1 intersection S2. Okay. So what do you think? Is there anything common between these two sets? No. That is why it is an empty set, intersection. There is no common record between both the set. But if I make some common record intentionally, let's say I put 12 here also, now you will see the difference. 12 is a common element, so intersection, correct? Then the third command is difference, S1 difference S2, correct? So S1 is this and S2 is this. There is only one common element, 12, so which will be removed from set S1. So this is the S1 difference S2 by removing 12 from set S1. Similarly, when I say S2 difference S1, it will remove 12 from S2. These are the remaining elements in the set S2 after removing 12. Then S1 dot symmetric difference S2 means all except the common elements within both. Symmetric difference means it will exclude 12. See, all the elements are present except 12. Then S1 dot is joined. Is joined, it's a Boolean function. Disjoint a function which returns true if no elements in both the sets are common. But we see that there is 12 which is common, so it is returning false, disjoint. Then subset, S1 is subset of S2, which is false. S2 is S1 is superset of S2, like in other words, S2 is subset of S1, which is false. Both of these situations are false, right? So these are all the topics which we wanted to study about in set, and along with that we have some exercises as well, right? So please try to watch this video properly. If you're not able to understand anything, let me know in the comment section. Let us have a healthy discussion there. And yeah, so that's all for set. I'll see you in the next lesson where we'll try to cover dictionaries in Python. And if you're enjoying these tutorials, if you're able to learn something and if it is actually making some impact, right, helping you to learn Python in an easy and practical manner, please consider liking this YouTube video, subscribing to the channel, and share this video with your friends who wants to upskill themselves in Python, right? So that's all for this video, and I'll see you in the next video. Thank you.